Well, following that exercise that I said I would avoid if I were you, we've got an exercise that has some arguments to be proven valid, argument forms to be proven valid in 2 steps. Following that, some argument forms to be proven valid in 3 steps. Then a section in which the author doesn't tell you how many steps the proofs are, but I always will. This is on page 365 of the 12th edition. I think maybe 253? No, that can't be. Check 253 of that new edition, see what you have on the 14th edition.
353.
That's going back too far.
Yeah,
huh?
that's going way back too far.
353 maybe.
I'm on.
What do we have? .349 of the 349 of the 14th edition. 365 of the 12th edition. This is number 2. Don't know how many we'll get through today. They supposedly increase in difficulty as you go through the exercises. We got through 16 in the first class. I don't know if we'll have time for all that tonight. But we'll start with number 2. You'll notice in the book the premises aren't numbered. That's something we do. However, they will be numbered on your test. So you also have the numbers of the proof steps on your test. Well, the question is not only exactly what is the thought process involved in completing the proof, but how do you go about completing it in the fewest number of steps? Because I could prove this argument form valid in 100 steps if I want to. It would be redundant, but if I don't violate any of the rules, it's a good proof. Okay, the way we're going to learn this proof procedure and to complete them in the fewest number of steps, the fancy name for it is retrograde reasoning. The normal name is simply backwards or reverse reasoning. In which case, we determine what the last step of the proof has to be, first of all. And then we ask, what would have to be accomplished prior to that? And if it's a 3-step proof, and prior to that, or a 5-step proof, and prior to that, and prior to that. The first thing I suggest you do, and we're always going to do this in class, is look over the premises of the original argument and anticipate how they might be used in our 9 rules of inference. For example, that first premise is a conditional statement. So that could be used as the first premise of modus ponens, right? Right. At the same time you determine that, also determine what your conclusion would be. So if that were the first premise of modus ponens, and that's how we extract the consequent of a horseshoe, we would be concluding E. Your first premise of modus tollens is also a conditional statement. So the first premise of our argument might be used as the first premise of modus tollens. And you should be able to tell me what we would conclude. I mean, so long as we have the second premise. It would be curl D, right? If you look at modus tollens, you'll see that's how it goes down.
Curl E, right?
No, curl D in modus tollens.
The second premise will be curl E.
No, I said what would we conclude
Oh, okay.
from it if we had the second premise, or maybe I misspoke. I meant to ask what would the conclusion be? Curl D, right? That could also be used as the premise of absorption over there. And you could see what we would conclude from that. That could be used as either premise of hypothetical syllogism. No telling what we would conclude because we don't have, the missing premise. Line 2 is a conjunction. we only have one use for a conjunction. And that is, over here, simplification. And if we use that as the premise of simplification, what would our conclusion be in that case? D.
D.
Now, simplification only has one premise. We should all know that I could have D anytime I want it. Right now, I mean, anytime. It's waiting to be happy. Now, I'm not going to go through this next thing too much. I mean, I'm going to say it a few times and then leave it alone. No matter how complex a premise is in our original argument, it could be substituted for a premise in our rules that is just a simple statement variable. Because anything can be substituted for a simple statement variable, right? So either of those could be the second premise of modus ponens. Either of those could be either premise of conjunction. Either of those could be the premise of addition. See, that's so basic, I'm not going to repeat it too much more, but you should be aware of that, because sometimes that's how you're going to use them. Okay, what we just did is we looked over, we saw what we had to work with. It's like looking at your hand when you're, playing cards. I don't know if you play cards anymore with actual physical cards. But, that's what you do. You look them over and you anticipate this is how they might be played. This is very important because if you recognize what could be done with those premises, almost always it is going to be done, or at least some of what you recognize, and you're ahead of the game. See? Okay, did we have a question here? Was that?
Oh, no, I'm just going to say, can we induce that as modus ponens because of what we have to work with? Is that where you're going with it? I was trying to anticipate the next step. We don't want to anticipate that far ahead right now. I see what you're looking at, but that's nice, but that's not what we're going to do right now. Too far ahead, okay? Now, the actual proof procedure begins by determining if your conclusion exists in the premises or not. Because if it does exist in the premises, then the last step of the proof is going to be to extract it. That's why we have these separated into rules that extract something and rules that create something. On the other hand, if your conclusion, the conclusion of the original argument, does not exist anywhere in the premises, the last step of the proof has to be to create it. There's no place to extract it from. Are you with me? Okay. So what can we determine? Does our conclusion exist anywhere in the premises? Yeah.
It sure does. It's in line 1. And then you need to determine, can I extract it from line 1? Well, it's the consequent of a horseshoe. Can we extract the consequent from a horseshoe? Yeah, it's modus ponens. That's why you have to know these rules. If you know the rules, this procedure is a snap. If you don't, it's virtually impossible. So we're going to anticipate that the very last step of the proof, is going to be to extract E from line 1 using modus ponens. And we have line 1 ready to go, the first premise of modus ponens. Okay, if you have the first premise of modus ponens, you should know what the second premise has to be. It's always the antecedent to the first premise. So what do we need as a second premise in this case? D. Okay, when we use these premises, they've got to exist on lines by themselves, and D does not. So prior to this last step going down, we have to obtain D on a line by itself. And you'll notice I'm keeping tabs of my notation so we could transfer it to the actual proof. That notation that we learned before the break, right? E is going to be the last step of the proof, line 4. First premise of modus ponens is line 1. So you want to keep tabs of that notation as you go through this procedure. Okay, so we ask ourselves the same question. Does D exist
anywhere in the premises so that we might extract it. If not, we're gonna have to create it. But D does exist. In fact, it exists in both premises. I think we all know how we're getting it, but I want to point out something to you right now that is real important when these get more difficult. It's just as important to know what can't be done as it is to know what can or must be done. Because if you don't understand what cannot possibly happen, you're going to waste a lot of time trying to make it happen and get frustrated, thinking that you don't know what you're doing. So let's suppose we try to extract D from line 1. It's the antecedent of a horseshoe. Those are our 3 rules of extraction. Do we have any way of extracting the antecedent from a horseshoe?
No.
No. So there's absolutely no way that D is coming out of line 1. You understand that, right? Okay. In line 2, D is the left-hand conjunct of a dot. Do we have a means of extracting the left-hand conjunct from a dot? That's right. So the second to last step of our proof is going to be to extract D from line 2. I'm keeping track of the notation there, so you know what to write in the actual proof. Line 2 exists, so I'm checking them off, and I circle what's not ready to go. So D will exist when we get back to the future for our last step of the proof, and it'll be line 3. And now we just have to produce it over here in the correct order. That's the first step of the proof, the one we figured out last. Get it? So do you understand where I'm getting these numbers from? I was keeping tabs on the notation over there. It's all ready to go. Questions about that particular proof? No? Good. Let's do the next one. This would be number 3. You know what, I'm going to skip 3 for now. It's a little bit more involved than 4. Let's start out by looking over our premises. Well, we just had an argument formed with a conditional statement in it. So you know everything that could be used for, right? Modus ponens, modus tollens, absorption, hypothetical syllogism. And it could also be substituted for any premise in the 9 rules that is just a P, just a Q. Second premise is just a simple statement. There's not much you can do with that. That can only be substituted for a premise in the 9 rules that is just a P or just a Q. For example, that could be the second premise of modus ponens. It could be either premise of conjunction. It could be the premise of addition. You need to check that out when I point that out. All right? Now, this is my personal terminology. It's not official. I call that a setup. We're looking at the premises. They're even in the right order for one of our 9 rules of inference. I'd like you to find out which one it is. It's over here. I'll give you a tip. We're looking at the premises of what rule? Modus ponens. Ladies and gentlemen, they're there for a reason, and you have to have sight recognition of that, which most of you will pick up just by working in class or whatever you do at home. So, if we were to use those as the premises of modus ponens, you should all be able to tell me what our conclusion would be. K. All right, we could have K anytime we want it. We have everything we need. Should we need K? there for the taking. But to begin the actual proof procedure, you always ask the question or determine, does my conclusion exist anywhere in the premises? If so, the last step of the proof will be to extract it. If not, the last step of the proof must be to create it, because there's no place to extract it from. So, does our conclusion exist anywhere in the premises? No. So the last step of this proof is going to be to create K wedge L. Furthermore, you need to note what kind of a compound. All of our creations create a compound statement form, right? So if a conclusion has to be created, you need to note what kind of a compound statement am I creating? A wedge. There are two ways to create a wedge. You all see what they are. Constructive dilemma and addition. All right? Now, it could be either one of those or it could be just one of those, but normally I suggest consider addition first, because it's a very simple argument form. And it should be an easy matter to determine if that's going to happen or not. Whereas constructive dilemma is rather complex, right? So this is an assumption because we have a choice. Let's assume that the last step of our proof is going to be addition. Okay, so ladies and gentlemen, if you have the conclusion of addition, the actual statement, big letters, if you have the conclusion of addition, you should always be able to determine what you need as a premise, right? So in this case, what do we need as the premise for addition? K, good. Okay, does K exist on a line by itself such that we could just go ahead and conclude K wedge L?
No.
No, it doesn't. So I'm going to circle that. We've got to get that on a line by itself, all right? And now the same question. Does K exist anywhere in the argument? If so, it'll be extracted. If not, it'll be created. Does K exist? Yeah, it sure does. It's in line 1. It's the consequent of a horseshoe.
Disjunctive syllogism.
No.
No?
We extract consequence from horseshoes by modus ponens. It's the only way. And in fact, that's our setup that we noted when we were looking over our premises, right? We said those are the premises of modus ponens. I could have K anytime I wanted. Well, we want it. So get it. Right? That's how we're going to get it. You keep tabs on your notation over there so you can simply transfer it to the actual proof. This then is going to be line 3. It'll exist when we get back to the future. It doesn't exist yet, but it will. It'll be there waiting for us. So this is the last step of the proof. That's the second to last step of the proof, or in this case, the first, right? So, first of all, K, there's a notation right there, ready to go. 1, 2, modus ponens. K wedge L. There's our notation, line 3, addition. It's fairly simple if you follow this procedure, and of course you've got to know your rules and what they're used for. If you don't, I have no idea how you're going to do this. Don't expect you to know them tonight. But you do. I mean, look at this as a game. Really, and these are the rules. And it actually becomes pretty fun and challenging. In fact, the better you get, the more difficult they are. It's nice. It's good. Most of you will enjoy it. But you got to know the rules of the game or you're going to get squashed by somebody who does. Not that we're a competition. Any questions about that particular proof? Okay, this is all our reasoning. That doesn't go on your test paper. Goes on your test paper right here. You're going to do that on scratch paper for me.
So that's,
What?
You have to race it. The 1-2 on the side of it, the 1-2 modus ponens, that's what's gonna be on, that's what you're gonna wanna see on the test, not necessarily how.
What we have here is what's on it. You write on the test.
Yeah,
You don't write that on the test paper.
but after that line, you had like the 1, 2.
I can't remember.
Okay.
Tell me if it comes up.
I'll tell you
again.
too.
Yeah, tell me if it comes up again. I'm gonna go to number 6. I'm saving 3 for a little bit. Let's look over the hand we've been dealt. Line 1 is a conjunction. Pretty much only one thing we could do with that. Simplification, right? Right? Okay. If line 1 were the premise of simplification, what would our conclusion be? Yes, P, thank you. Does everybody get that, right? Not much you could do with a simple statement. That could only be substituted again for a variable by itself. P, Q. Question, does our conclusion exist in the premises?
Not,
No. No, it doesn't. P dot R, does it exist in the premises? No. So the last step of the proof is going to be to create it, right? Either extract or create. You guys are following along. Okay, so the last step of the proof is to create P dot R. And it's going to be line 4. That's the last step of the proof. There's only one way to create a dot. How do you create a dot? Conjunction. So let's keep track of what we're thinking here. Oops. I wanted to ask you that. If you have the conclusion of conjunction, whatever the conclusion is, you should always be able to determine what the premises are, because they are the conjuncts of the conclusion, right? So we need, on one hand, P, and on the other, R. Do we have either of those on a line by itself, ready to go? Which one?
2.
We have R. Don't have P on a line by itself, so that has to be accomplished prior to this last step. You get that? All right.
Extracted through simplification.
Question, does P exist on a line by, well, we already said no. Does it exist anywhere in the argument? Yeah, only one place, line 1. And it's the left-hand conjunct of a dot. Can we extract it?
Simplification.
Yeah, so notice again, when we looked over the premises, before we even started the proof, see, what we notice is in fact going to be done. So you don't want to neglect reviewing the premises before you even begin the proof procedure. You'd be way ahead of the game, because you already have it in your mind. What can and will be done. Okay, so we plan to extract P from line 1. So again, I'm keeping track of my notation there, okay? P therefore is going to be line 3. It's the next to the last step of the proof. So I'll put my 3 here as well. We'll check it off because it'll be there in the future when we get around to it. So that's the last step of the proof. This is the next to the last. In other words, in this case, the first step of the proof. You see how we're working backwards from the last step to what must be done immediately prior to that. And as they get longer, it's just more of the same. What has to be done prior to this and prior to that. So, yeah, that goes all on your scratch paper for testable purposes. This would be printed on the test paper. So you figure out your proof and you just write in the lines of proof, right? Notice 3-2, not 2-3. We all get that, right? Why it has to be sequenced that way? Okay. I think a couple more of these you'll be ready to strike out on your own. I didn't mean strike out. Go for it on your own. Questions about that particular proof? No? Yes?
That means our test is gonna be like fill in the blank, no longer Scantron, right?
It's not a Scantron test. No. I've got to actually check. I get to check your work like a math. I'm still going to wait on number 3. Go to number 8. Look over your premises. Find out what they might be used for, and if possible, what the conclusion would be. But you'll notice we have there again what I call a setup, which is exact substitutions for the premises of one of our argument forms. They're even in the right sequence. I mean, they're staring us in the face. Those are the premises of what argument form? Disjunctive syllogism, right? So, if we use those as the premises of disjunctive syllogism, what would our conclusion be in that case? W, yes. We can have W anytime we want it. We have everything we need to conclude W. Now, our conclusion does not exist in the premises. So the last step of this proof is going to be to create a wedge. There are 2 ways to create a wedge. You know what they are, right? And you know which one I suggest you try first. I want to point out something else to you right now that could be valuable. You'll notice that the conclusion has a statement, X, that does not exist in the premises. It has to be addition. Can't be constructive dilemma. Because every simple statement in the conclusion of constructive dilemma exists in the premises. See? Whenever you see a simple statement, one big letter, a simple statement in the conclusion that's not in the premises, the only way to introduce a statement that does not exist, the only way to introduce it into your proof is addition. Because addition says, given any premise whatsoever, I can conclude the disjunction of it and whatever I want, even if what I want doesn't exist in the argument. You all get that? Okay, so we are anticipating that the last step of our proof is going to be had by or created by addition. Again, if you have the conclusion of addition, in any case, you automatically know what the premise is that you need. You need the left-hand disjunct of that conclusion. In this case, we need what? W. I think W does not exist on a line by itself. So that has to be obtained before we can do this. And you all see how we're going to get it. And again, you see, it's exactly what we anticipated when we looked over our premises. Again, don't neglect that step. It's crucial. So we're going to extract W from lines 1 and 2 by disjunctive syllogism.
You know how I know that's gonna be line 3, right? It's a two-step proof, that's the second to the last step. So put it in down there. W will be waiting for us when we get back to the future. And this is the actual proof. Questions about that proof? See if we're ready to go forth on our own. Yeah, I've got one for you. Let me point out something to you that you might not like, but frankly, I don't care. There's a format to this proof procedure. By format, I mean appearance. And there's a format to every proof procedure. It's important to us in math and geometry and logic that that format be followed exactly. There's a reason for it. So I want you to get in the habit, especially with your notation, of producing it exactly as it appears in the book and the way we do it in class. That means numerals before the abbreviations. Or it's wrong. We put commas after our numerals, or it's wrong. These abbreviations are specific. They're case sensitive. Sometimes you use uppercase letters. Sometimes you include lowercase letters. And of course, there are periods at the appropriate places in the abbreviations. Now, that's not asking you to do something outrageous. You know, you might not understand why the attention to detail. We have reasons for it. So if you don't reproduce that format exactly, that line of proof is wrong, and you don't get to use it in further deductions. So let's all get into the habit of being real neat, nice and neat, right? And actually composing our proofs and presenting them. Okay, we're going to see how you do on your own. You could talk it out with each other. It's the same question and answer procedure that we've been doing for an hour. I think number 9 is actually easier than the ones I'm saving. Oh, setup. Look over your premises, anticipate what they might be used for, and if possible, what the conclusion would be. Then begin your procedure by asking the question about the conclusion. Give our students at home some background score.
Let me redo that.
So that was line 4.
Line 4 was